Alright, we're looking at trig identities in this video, and some of these we've already talked about. We've mentioned how the tangent of theta is equal to sine over cosine. We talked about how if we have sine squared plus cosine squared, that's going to equal 1. That came from the unit circle. Okay, these are given to you in your formula packet. Now these two here are kind of offspring of this one up above. Sine squared plus cosine squared equals 1. So if you wanted to solve for sine squared or cosine squared, we can do that just by moving some terms around. Now, we're going to move into double angle identities. So by double angle, that's where we're talking about 2 times theta, right? So it's a double angle. So the sine of a double angle, and this is given to you, it's 2 times the sine of this single angle times the cosine of the single angle. So this 2 theta here is going to be 2 times whatever you see here. So if this were 80, okay, if it were the sine of 80, it'd be 2 times the sine of 40 times the cosine of 40, okay? So in this part, it's always half of what you see in this first part. Likewise, we have a cosine of a double angle. Now here, notice there are 3 different identities. And by the way, when we talk about identities, we're talking about something that's identical to it. So these are 3 identities. Notice how the first one has a sine in it only. The second one has a cosine only. And the third one here has both a sine and a cosine. Okay? So these are all given to you in your formula packet. So now let's see these used in some examples. Okay, in this example we are looking to find exact values of a few things. The first thing is the cosine of x, and we are told that the sine of x is 3 over 4, and our angle x is between 0 and 90 degrees, so that means of course we are in quadrant number 1. So if we're going to find the cosine of x, all right, understand there's a couple different ways of approaching this. One way is to say, all right, first quadrant, that's where we're talking here, our angle is x. If the sine of x is 3 over 4, that means the opposite side is 3 and the hypotenuse is 4. Okay, so if we find this missing side here, if we call it b, we know that b squared plus 3 squared equals 4 squared. So if we clean this up, this missing side would be radical 7. Okay, so if we wanted to then find the cosine of this, well, cosine is adjacent over hypotenuse, so the cosine would be radical 7 over 4, and it would be positive there because of the ASTC idea. We know that in this quadrant all 3 trig functions are positive. That's one way of getting it. Another way is to use the identity, and we saw a similar example to this earlier in a video, but the cosine squared, or sine squared of x plus cosine squared of x is equal to 1. We could use this identity, so we know that if we were to rewrite this, it's really going to look like this. Okay, that's what it means if it's squared. So we know that the sine of x is 3/4. Okay, we're trying to figure out what cosine of x is. Okay, so from here, if we were to clean this up a little bit, our cosine of x, if I were to get rid of the square, I'm going to have to square root something. Well, we would have that 1, and then I'm going to subtract over 3/4 squared. If you square 3/4, you get 9 over 16. Alright, from there, you're expected to do this without a calculator. Alright, we know that 1 is 16 over 16 minus 9 over 16. So from there, this would give us a square root of 7 over 16, which if we apply that square root to both top and bottom, notice how we get the same answer, okay, of radical 7 over 4. So you're not expected to do it both ways, of course. You have to choose the way that makes the most sense to you. Okay, suppose next we want to find the sine of 2x. Well, our formula is telling us that this is equal to 2 times the sine of x times the cosine of x. So now it's just a matter of substituting in. We know that the sine of x is 3 over 4, and the cosine of x is going to be replaced with radical 7 over 4. Okay. From here, we're just going to multiply straight across. You could think of this 2 as being over 1. So you're going to have 6 radical 7 over 16, or 3 radical 7 over 8. Okay, in our next part here, suppose we want to find the cosine of 2x. Now recall from the previous page, there are 3 identities that we can pick from. Now, since we know both the sine and the cosine, it does not matter which one we pick. I'm going to pick the one with a sine only, so we don't have to deal with that square root of 7. So the one with a sine only is 1 minus 2 sine squared of x. And again, you're expected to know how to do this without a calculator. So we know that for this piece right here, the sine of x is 3/4. So I'm going to replace sine of x with 3/4, and then I need to square that. Okay? So, by the way, a lot of times I see people will replace just x with 3/4, and they want to write the sine of 3/4. All right, the sine is gone. All right, look back up here. The sine of x is 3/4. So the sine of x is replaced with 3/4. So from there, you have to remember your PEMDAS. So you have to do this first. Okay, your power comes before multiplication. So that's going to be a 9 over 16. Again, need to be able to do this without a calculator. The biggest mistake I see next is people want to double both the 9 and the 16. Okay, this is going to become just 18 over 16. It's not going to be 18 over 32. Okay, think of this as 2 over 1, multiply straight across. So this 1 is 16 over 16 minus that 18 over 16. So I'm getting a common denominator. So that's negative 2 over 16, which is our final answer. However, it would look better if we write it as negative 1 over 8, okay, if you were to reduce it. All right. So again, if you used, and I would encourage you to use the other 2 identities and work through it and prove to yourself that you're getting that same answer. Okay, and finally here, if we're looking to find the tangent of 2x, well, recall that this is the sine of 2x over the cosine of 2x. Right? Remember how we said the tangent of theta is equal to the sine of theta over the cosine of theta? Well, by theta, we just mean that these angles must all be the same. Well, we've already done the hard part. The sine of 2x we found up above was 3 radical 7 over 8. And then the cosine of 2x we just found to be negative 1 over 8. Well, notice how these are both being divided by 8. You could think of this as, let's multiply top and bottom by 8, all right, and that'll wipe out those 8s. So we're left with 3 radical 7 divided by negative 1, which is just negative 3 radical 7 for our final answer. Okay, last example here. So we're given that the cosine of theta is 4 over 5, and we're told that our angle is between 3 pi over 2 and 2 pi, which you know hopefully means quadrant number 4. Okay, so if you were to draw this out here, which I encourage you to do, all right, understand that this is our theta, and its cosine is 4 over 5, so the adjacent over the hypotenuse is 4 over 5. Well, this is a nice triple, 3, 4, 5 triple. All right, 5 is the hypotenuse, so that means the legs are going to be 3 and 4, right? So it's pretty easy to find our sine of theta. Sine is opposite over hypotenuse, so it appears to just be 3 over 5, but be careful. Remember that in this fourth quadrant, only cosine is positive, so that means we have to slap a negative in front. Now, if you had used your formula, sine squared plus cosine squared equals 1, watch what happens. So jot this down. If we were to use the formula, if we once again replace cosine of theta with 4/5 and then do the algebra to solve for sine of theta, so you're going to have to square 4/5, subtract it over from that 1, and then square root. Notice we get the square root of 9 over 25, which ends up being positive 3 over 5. It's very tempting to think that's the final answer, but once again, you have to recognize that we are in the fourth quadrant, okay? and that means that sine is going to be negative. All right, so cosine of 2 theta. Again, you have 3 formulas to pick from. This time, let's use the 2 cosine of theta squared minus 1. Okay, again, doesn't really matter. So the cosine of theta, we know just from the givens, that's 4/5, okay, squared, and then minus 1. So maybe let's say you couldn't figure out part A, you can still do part B based on this given fact up above. Okay, so you just have to very carefully do your order of operations. So you have 2 times 16 over 25 minus 1. Guys, I find every year that people are okay with this substitution. It's the cleaning up, it's the doing it without a calculator part that throws people off. Again, when you do 2 times this 16 over 25, I can't tell you how many people are tempted to turn this into 32 over 50. All right, only the 16 gets multiplied by 2. So it's going to be 32 over 25 minus 1, and 1 is really 25 over 25. Okay, so you're simply getting a common denominator like that, and then we're going to get 7 over 25 for our final answer. Now for these double angle ones, you don't have to worry about things being positive or negative. You don't have to worry about your quadrants, okay? That's only if we're talking about a single angle, okay?